So welcome to my walkthrough for the Edexcel Higher paper. It's from the June 2023 series. It's paper 2, so calcs at the ready and into action straight away. So obviously I've done this one in advance. If you don't get the right answer, make sure you do put some brackets around the numerator and denominator. And there's no need to round off, just write out exactly what you see in your display. Part B, reciprocal always means 1 over. So obviously on your calculator, press that, hit equals, and it should give you the 1.6 for the right answer. Number 2, prime factors. Factor trees. I'll go 12 fives. And to speed things up, don't be afraid of three-way splits. 3 twos are 6, times 2 is 12. It doesn't ask for index form, but I'll always use index form. Speeds the process up. Number 3, very waffly for a 1 marker, so don't waste time filling in all 3. Alright, at the end of the day, 48 counters. As you can see, if a ratio is 1 to 2, that means the red counters will account for a third, 1 out of 3, and the blue will account for 2 out of 3. So you could go down the fractions route, and so that obviously disregards the half. If you wanted to actually work it out, that means you get 16 to 32. But either way, don't waffle for too long. In 4 for standard inequalities. Greatest possible value, so you look at the upper end is a 5, but we haven't got an equals to, so you need to go 1 below. On the number line, show the inequality, so a circle at -4, a circle at 1, we have an equals to, so it needs a closed circle on 4 and an open circle on 1. And for C, solving, it's a weird looking one. Don't worry about the inequality, just think of it as an equals sign. Basically, just ignore it. I'm going to add 4 to both sides. At this point, you could take your calculator because you need to divide both sides by 2/5, and that will give you the right answer. I'll try it the non-calc way, so start with 10, times by 5 is 50, divide by 2 gives us 25. Question B. So we've got some algebra going on. Now, as soon as it mentions the word area, I look at this, it's a triangle. We do a half times the base times the height. So that's 4 times 6x. So that's 24x centimeters squared. The area of this, 5 times 4x, 5 times -1. The area of the triangle is 10 centimeters greater. So if we take the area of the triangle and subtract 10, we get the area of the rectangle. We now have to start solving it. So I'll take away 20x from both sides. I will add 10 to both sides. So x equals 5 over 4. Perfectly acceptable to leave it like that, or 1 1/4, or 1.25. It was 6. Wordy, kind of, percentages and ratio, lots going on. Last year a family recycled, so 50% of. So on your calc, of means times, percent means out of 100, and 800. Stick it in. So in real time, 57 divided by 100 times 800. So in other words, 456 kilograms is paper and glass. So to split it to paper and glass in the ratio of 12 to 7, it only wants glass. So glass is 7 out of 12 plus 7 is 19 shares. And as usual, of means times. So 456 times by 7 19ths. We get 168 kilograms. On we go. Number 7. It's been rounded to 1 decimal place. As always with errors, you need to go up and down by half the rounding amount. So it's been 1 decimal place. So think of it as cash. That's nearest 10p. So we need to go up and down by 5 pence. So add 5 pence on. It's okay to have 49 recurring there, but take 5 pence off and we get 12.65. Number 8, typical percentage question, one thing at a time. So Tamsin buys a house. Let's start with Tamsin. 150 grand, 4% each year. Write down your multiplier. Rachel buys a house. Let's leave a bit of a gap and go on to Rachel. £160, £160,000 increases by 1.5%. At the end of 2 years, so in it goes, and we reach for our calcs. So 150 treble O times 1.04 squared. For Tamsin, I'm getting 162,240. And for Rachel, 160 grand times 1.015 squared. I'm getting 164,836. Always make sure you answer the question. Whose house has the greatest value? Rachel. And the numbers clearly shown. On we go. I've cheated a bit for number 9. I've done them already. So as you can see, it's already done cumulative frequency for you. So that's on the next page. I'll show in a sec. Make sure when you do cumulative, you plot the upper boundaries. So you should be using your first coordinate should be 30, 20, 40, 48, and so on. And when you want the median, middle means 40.5th technically, but thickness of a pencil, who cares? It's estimate. Mark scheme allows a bit either way, as you can see. But there's my attempt. I've cheated because you don't want to see me be rubbish with an electronic board pen. So plotting those coordinates, there's your 40. As you can see, my answer, there's 35, 36. I'm coming out about 37. That'll do. Number 10. Bias dice. Estimate for the probability will land on 6 both times. So, probability of a 6 happening, also known as relative frequency, because it's based on an experiment. It's happened 15 out of 60 times, and happening again is 15 over 60 times. Stick that in your calculator. It's a 16th. Sally's going to throw the same dice a number of times and record it. She'll use her results to work out a more reliable estimate. So in order to be more reliable than these probabilities, you need more trials. More trials means more reliability. So she needs to do the experiment more than 60 times, or something like 61 or more, anything like that. It's only worth a mark. Load simultaneous equations, you know it's coming. Your choice. Do I make the x's into 6x or the y's into 12y? I'm going to go for 6. So I'm going to take the first equation and treble everything. So I get 6x, 18y, 15. I'm going to take the second equation and double everything. So 6x minus 8y minus 24. Because I've chose to make the x's the same, they're both positive, so it's same sign, subtract. They disappear. 18y minus negative means plus. 15 minus minus means plus. So 15 plus 24 is 39. Use your calc. 39 divided by 26. 1.5. In it goes. I'll pick the top equation because it avoids negatives. So it just looks, and numbers are smaller, bit easier. So 2x stays the same. 6y's or 6 1.5's, that's 9. And we just come with solving. Subtract 9 from both sides. Halve both sides. We get negative 2 for x. Number 12, got a little bit of a head start here. Because the idea is to work out the circumference. Circumference is 2 times pi times the radius. The radius of the circle is there, O to B. And there's your problem. Now what's your solution? It's hidden Pythagoras. So the height of this triangle is 5. The width of this triangle is 4. Let's do some Pythagoras. The radius. 4 squared is 16. 5 squared is 25. Added together, because we're wanting the longest side, is 41. Onto our calculators. 2 times the root of 41 times by pi. I'm getting 40.2244, etc., etc. 3 sig figs required. I'll stop at 40.2. Number 13. So calculate the size of angle BAC. B to A to C is here. I'll call it X. So, one of those where X, well, it is a sine rule question because we have an angle and an opposite side. So we can write sine 70 over 18. Problem is, for X, we don't know that. Now you could go some long convoluted way about it, but really, if we find Y, we've got angles in a triangle make 180. So let's find Y. So sine of Y over its opposite side of 15. So times both sides by 15. We'll get a horrible decimal, but let's see. So 15 times sine 70 divided by 18. I'm getting a horrible answer. 0.783077 and so on. So we need to shift sin or inverse or whatever button your calc has. And I'm getting the answer. It wants one decimal place. That is 51.543-ish. So we now do 180 minus the 70 we knew, minus the 51.543 we've just worked out. I'm getting 58.457. One decimal place, 58.5. Next. Question 14, show means do. So on the top, let's get it factorised. So it's going to be two numbers that multiply to make -6, add to make -1. So it's -3 and +2. And you could use the AC method on the bottom, but I wouldn't, because the clue is that one of these brackets will repeat. So let's just test it. If that's -3, over here we would need +1. Does it work? Well, 2x times -3 is -6. 1 times x is +1. Yes, that way round does work. That was a legit guess. So obviously if I got it wrong, I'd try the +2 and so on. But there we go. So we've got it factorised. We've got it cancelling. We can now write it in the form they wanted. So x plus 2 over 2x plus 1. Number 15. Quadratic sequences. So differences, 6. And what we got there, 8. And we've got 10. So our second differences, which confirms it's an n squared sequence. Second differences are 2. We halve that, so it's a 1. So let's not bother. Let's look at our square numbers. 1, 4, 9, 16. How do we get from 1 to 3? That's 2. From 4 to 9, that's 5. From 9 to 17, that's 8. And from 16 to 27, that's 11. We have another sequence to work on, so start again. This sequence is going up in 3s. That means there's a 3n to it. What does the 3n, the 3 times table, look like? As you can see, it's take away 1, take away 1, take away 1, minus 1. There we go. So here we've got a histograms question with the key being no labels on the frequency density. So let's look at widths. That's 20, that's 10, that's 10. 28 students are 30 to 40. So that's that chunk there. So area is 28, width is 10, so height is 2.8. And that now gives us the scale. That must be 3, that must be 2, and that has to be 1. Use this information to complete. So the next bar, the missing bar, which goes from 40 to 60, in other words, a width of 20, we need to know its height. So to do height, we do area divided by width. In other words, 1.2. So we find the 1. Let me get my pen. We need to go up to 1, but up to 1.2. There we go. And we finish off the bar across. I won't scroll down, we can just see part B on the bottom there. So as you know, that bar is 28, this bar is 24, work out there are no more over there. So we need the sizes, the areas of the others. So this bar here goes up to a height of 3.6. So there's 36 in there. This goes up to a height of 16. So there's 32 in there. So 32 and 36 and 28 and 24 means we have a nice looking number, 120 students in the diagram. So for number 17, we start with a bit of rearranging, with the clue being the fourth root is the last thing to be done. So the first things to be done is add your x squared and your 5 to both sides before you take fourth roots. And the key is it's that middle line there. That's what the examiners want to see. Next, this is where you need to learn how to use. If you don't know how to use the A and S button on your calculator, it's a massive advantage. So you can put the fourth root, open brackets, x squared plus 5 or 1.5 squared plus 5 in your calc. Depends on how you feel about using the A and S button. I personally would do the first iteration normally, stick the 1.5 in, and then leave that in your memory. And then when I type in the next bit, I would type in fourth root brackets ANS squared plus 5 and repeat and repeat. Now, how accurate you write your answers doesn't matter. They're not specifying anything. Doesn't matter how accurate. All right, I just wouldn't bother with one decimal place, anything more than that. All right, because it started in one decimal place. I was working at least 2, and your final answer, 2 or more, no one really cares. So for number 18, we've got one of the least friendly looking linked ratio questions I think I've ever seen. But here we go, let's take the top equation. If you've got 2a to 5c being 6 to 25, you can just read in that a must be 3 and c must be 5. Let's take the bottom line. I'll not write it out because you get the gist of it, but 4b to 20 tells us that b is 5. 7c to 21 means that c is 3. So this is where the linked ratio part comes in, because they're not linked, but C can link them. So A to C is 3 to 5, B to C 5 to 3. So as you can see, we can make these the same by going to 15, by timesing by 5, and by timesing by 3. So now we can say that A plus B, 9 plus 25, to B plus C, 25 plus 15. And look what happens when we halve them. Yeah, not the friendliest you'll ever see. So for number 19, we've got errors and trigonometry clashing. So each of these numbers has been rounded off to the nearest millimetre. So for your upper and lower bounds, you need to go up and down by half of that amount, or in other words, nearest 5 pence, if you'd rather think about it in terms of cash. So 12.65 and 0.55, same here, 9.35 for the upper limit and 9.25 for the lower. So from the angle X, we've got the opposite and the hypotenuse. That is our sine or part of SOHCAHTOA. So the angle for X is going to be the shift or inverse of opposite over hypotenuse. Now, in order to get the lower bound, we're going to need the smallest possible value. So to get the smallest possible value, we will need to pick the smallest opposite and the largest hypotenuse. So the smallest opposite, 9.25, the largest hypotenuse, 12.65, and we reach for our calculator. So inverse sin brackets 9.25 divided by 12.65, close them up. And I'm getting, it says must show all your working, doesn't ask us for any level of accuracy. So I'll just go 46.989. I'll stop there, it goes 213 and so on. But that will do. 3 dp's is more than enough. Number 20 for some vectors. As always with vectors, one bit at a time, add information to your diagram as it goes. O to T is A, that's already on there. R to T, so's that. M is the point, so that O to M is 2, and that is 3. So they are added together, 2/5, 3/5. Express M to T. So we need to get from here to here. Now the key for that will be which direction do you go? But no matter which direction you choose to go, you're going to need the distance from, you're going to need the vector O to R or R to O. Let's go O to R. To go from O to R, it will be A minus B. So to go from M to R, that will be 3/5 of that. And so because I've done M to R, I'm now going to do M to T. M to T will be what I've just written. That's that part of the journey, but we need to add a B on the end. And as usual, tidy it up, simplify. Minus 3/5 plus 1 plus 2/5 B. And there we go. Number 21, I've cheated, drawn it already, but that's so I can explain things. Only worth 1 mark. So as soon as you have a -4 on the end of a graph, that means move it down 4 units. So pick your key coordinates and move them all down 4. And the next bit is if you replace x with negative x, that means all the horizontal movements, all the movements left, become movements right, or in other words, you reflect in the y-axis. So that's why your shape should be appearing over there, but draw it neater than I've just done. So number 22, we've got a horribly worded and only 2 marks available. So we've only got blue and red in a box. 4 times. So whatever that is, there's 4 lots of. So the probability of getting one blue is 4x over the total, which is 5x. Or in other words, probability of a blue is 4/5 and a red is 1/5. Now, this requires a bit of a knowledge about what happens in probabilities. Write down an expression that Rita gets a blue pen at least once and a red pen at least once. So that means they've both got to happen. Well, the probability of them all being blue is that. The probability of them all being red is that. And the sum of all probabilities is 1. So the expression is 1 minus all blue minus all red, because you need to have at least one of each. So it's only those situations where you get all of one colour. In any of the other situations, you get at least one of each colour. What a strange one. So a weird one for number 23. Don't just assume they're cubed. That won't get you the marks. Bit more to it. So you're told that's 1, that's 2, and that's 3. So let's look at little triangle. That will have a side of 1. Bigger triangle, it's 1 plus 2. Biggest triangle, it's there. So not quite the multipliers you actually think. So if you've got a linear scale factor, let's not forget linear scale factor going to area scale factor, that's when you square it. So if the sides have a multiplier of 3, the area of 1 will have an area of 9, will have an area of 36. But these shapes aren't triangles. So what we have got to look at is the fact that the area of this is the big triangle, take away the small one. And the area of this is the big triangle, take away the one that's on top of it. In this case, the medium-sized triangle. That's where those cube numbers come from. But you can't just cube them, you need more to it. So showing this bit of working out here in your own way, doesn't matter how you best explain it, but in your own way, you can't just be cubing them. It's not about cubes. Number 24, I've already done a little bit of drawing on there because this one's a pain. So you're told that the octagon is A by A by A by A, or in other words, that's A, and so's that. So this distance here, you might not realise it, that is a 90-degree angle. However you think about it, because the external angle of an octagon is 45, internal 135, it's a 90. So that means we can apply Pythagoras. So the hypotenuse is 2a squared plus a squared. Okay, moving on. So that means there are 4 triangles. I'll use that as my starting point to start working on area. Those 4 triangles, they have a base of A and a height of A. So it's 4 lots of a half base times height. So 4 lots of halves is 2a squared. Now that's just a coincidence. Now we need to work on the area of the square. Obviously, we need to know how big the square is. So that distance there is A. That distance is also A. So part of the size of the square is 2A. But there's also that bit there. Good news, we've kind of got it. Because we know A squared plus A squared, 2A squared, let's not forget, needs square rooting. So it's A root 2 for the side length of the square. So we can find the area of the square now by doing 2A plus A root 2 multiplied by 2A plus A root 2. So we've got 4A squared, and we've got 2A squared root 2. This loop, 2A squared root 2. And the final one, A squared root 2 times root 2. There we go. So the total, let's not forget, also needs the 4 triangles. So we've got 4A squared and another 4A squared. We've got 8A squared. And here we've got 2A squared root 2, 2A squared root 2. So we've got 4A squared root 2. Now as they want the A squareds taken out and put at the end. They want a 2 plus root 2 in the middle. How do we get 2 plus root 2? By taking a 4 out. So in other words, P is 4. 4 times 2 times A squared. Bosh. 4 times root 2 times A squared. Done. Heck of a question. Yep, they gave you more room for it, but you can squeeze it in. Particularly like most of these sort of questions, you should do plenty of working out on the diagram. Some doozies there on the last 3 questions, I thought. Hope that helped. See you on the next one.